Hey, buddy, how you doing this week?
I'm good. How are you?
Super fantastic. So what I've gone ahead and done here is I've decided that that homework assignment that you gave us all was a thing that we would actually do.
Right. I actually gave it to you because I know you listen, and maybe other people too.
As one of our listeners, I've gone ahead and I've decided that let's go ahead and let's do this. Let's take a look at the homework assignment that we were given. Let's start with, installing
Mutillidae.
So as it turns out, we're not going to do that at all. It turns out that they've got...
What?
Yeah, I know, right? If you actually go to the website and you run a search for installing it, they've got really great instructions. So they're better than we would have produced, to be fair. So let's give it a whirl. Let's take a quick look.
Mm-hmm.
And again, we'll make this into a two-part where we're installing it and then, actually using it. So Iron Geek Mutillidae. And here we go. Look at that.
Boom. Found it. First try.
Yeah. Oh, so good. So as it turns out, they've made the instructions really, really simple. And they've also included the instructions on their site. So as you can imagine, easy to do, easy to use, all good. So run a search and this is what you're looking for. This is what it turns out to be, interestingly enough, is you install XAMPP and you run XAMPP, and XAMPP has this thing where it will create a folder for your installation.
Right.
And in that folder, there will be htdocs.
Mm-hmm.
And in htdocs, you extract the Mutillidae zip.
All
That's
right.
the installation done. You're done. So now, once you're up and running, you are to go to your local host, which in most cases is 127.0.0.1. You could regularly type localhost into the address bar. Localhost. And it would present you with XAMPP because XAMPP is running off of the local host. The only difference being Mutillidae will not allow you to run it through localhost. So instead, 127.
So if you saw that, it said it has Apache, MariaDB, PHP, and Perl.
Yes.
I guess that's what XAMPP stands for. And the X is for it's Windows.
Apache, MySQL, PHP, Perl. And
MariaDB.
Yes.
So right there.
There is a version of this called LAMP, which is for Linux.
Right.
And XAMPP is for multiple operating systems. So we're going to go 127.0.0.1/Mutillidae. And that brings us to the installation that we've created in our htdocs folder.
Perfect. And that's the one folder under it. Therefore, that's the folder that it finds. Cool.
There's some other folders in there, and we can visit them all, but we're not going to. However, Webalizer, XAMPP, test, anyway.
Right. So conceivably, if you went to /test, you'd end up somewhere else. But this is where we have it set up under Mutillidae.
Regularly, it's not going to be so wildly large, but I'm zooming in 150% because Max is working remotely and trying to read my screen. And also, for the sake of video. That having been said, this is Mutillidae. Do you want to give us a brief rundown as to what it is? What we're looking at?
So my understanding of Mutillidae is it's basically a purposely vulnerable web application that is vulnerable to the OWASP top 10. The OWASP is the Open Web Application Security Project. And the top 10 are the 10 top most common vulnerabilities that you'll find out there on the internet for web applications.
Awesome.
So the one that we're looking at right now is SQL injection, but you'll find cross-site request forgery, cross-site scripting requests forced browsing, all of the normal stuff that we've actually talked about in the past. But here's a platform of these purposefully vulnerable applications where we can test out and see how these things actually work. And we'll learn through playing and breaking in a safe environment, and then to be able to understand exactly how these things work. And it's important that we understand how these things work in a environment where we can actually do the queries ourselves, so that when we progress into the automated tools, we understand actually what's happening behind the scenes and we can start piecing these things together.
Absolutely.
So that's why we're taking these baby steps to begin with and not just loading up some other application.
Right. So they've included what should I do, some video tutorials, help me, a listing of vulnerabilities. They've got all of this in here. This is a fantastic learning resource, and I'm really glad that you introduced us to it. What we're going to be looking at today is SQL injection. Mm-hmm. And so with all of these injection options that we've got, we're going to go with the first one, extract data and user info. What this does is it brings us to a pretend web form. Please enter your username and passwords to view your account details. And then it asks for your name and your password.
Right. And so stepping through this as an attacker would, right? The attacker doesn't quite understand how the web page is supposed to operate the first time. So they would most likely go through the normal exercise of registering as a user in this case and seeing exactly how that works, and then seeing are there signs of vulnerabilities that they could then exploit, right? And this would be for the good guy hackers and the bad guy hackers alike. Exactly. So let's go through the first time, the normal course of information, the normal process of registering a user and signing on, and see how that works.
So obviously we're following don't have an account. Please register here. As a direct result, we're going to put in a username. I'll use my maiden name, Bill Gates. Mm-hmm. And I'll put in my password of password.
Right.
And then I'm going to confirm the password, password. And then a signature. Now, I don't really understand what it means by signature. Whatever. Let's put I like ducks. I will now create an account. So it is account created for Bill Gates, one row inserted.
Okay. So we're already starting to get back information already from the things that we're doing.
Yeah.
Right. So we're seeing that it's feeding back the input that we had put in originally about Bill Gates. That could be handy for later future attacks. And it's telling us that whatever we put in is making an SQL connection in the background and inserting the row. At least that's what it appears to be doing in front of us.
It's created something in presumably some sort of database.
Right. So we know that through this, we are somehow manipulating the database.
So now what we're going to do...
We could actually play around with this, but let's just go back and actually sign on as if we had created the account at a separate point in time, and now we're actually going to use it.
Bill Gates, and my password is password.
Of course it is. Why wouldn't it be?
Let's view my account details. Mm-hmm. So it's now giving my results for Bill Gates. The username is Bill Gates, the password is password, and it shows the signature. So basically, it's just going to display everything that I've been asked to create thus far. Were the initial form a little bit more robust, there'd be a lot more information there for us, but that's fine.
So there's enough here to prove the fact that
we're pulling it from the database.
Yeah, exactly right. It's not just echoing back what we typed in. It's actually going and retrieving the information like the signature of I like ducks.
So as we look at this, you have to keep in mind that on the web, you're not just looking at the page that's being displayed to you. There is, if you're nefarious, a lot of other information that's available here. Now, unfortunately, this I can't scroll or zoom into, but I don't know, Max, can you read this up here?
I can see that there's the index.php, which is the main page. Page equals user info.
I'm going to create a notepad just for us to dump stuff here. So
Okay, that's easier to view.
In the URL, we're getting this. So the web address, and then here is where it actually starts our request.
Yeah, so it looks like the main web page is calling a subsequent web page after that question mark. And then it's providing my username or your username and your password in clear text.
So already we know that we're not dealing with something that is using good practice because we're using a tool that's meant to not use good practices. But now we're actually seeing it, the proof. We're seeing the proof.
Right. So I guess there's different things that people could do to that toolbar to manipulate that.
Yeah, absolutely. The first thing that you can do is you can change it directly here. You don't even necessarily need to use the form. So if, for instance, I were to change my password to password 2, at this point, it doesn't recognize it because my username and my password weren't right.
That's right.
But that makes it a lot easier for anybody to write a script that's just going to say, okay, try password 1, password 2, password 3. All it's doing is it's writing the URL or overwriting the URL.
Right. And they can compare the results back. As long as the results always look exactly the same, you can discard those and just quickly cycle through all of these. You don't actually have to render it on the screen, which takes a lot of time. Right. So you can write the script and compare the results. As long as the results for Bill Gates is the username that you put in, you can enumerate through the user accounts and passwords and do a brute force attack against the page.
So now I'm going to tell you what I did because as it was assigned to me, I did the homework.
Okay.
The first thing that I did was I went online and I Googled SQL injection. And one of the things that I found was a really easy way to determine if something may be susceptible is if they are sending the URL or sending the request in clear text like this, from a web form standpoint, this is sent as post instead of get.
Right.
Not necessarily here nor there, but it's just interesting to know. So
all it means is that it ends up in the address bar rather than a behind the scenes invisible to the user experience.
Yeah, exactly. So post will show on the address bar, get will not show on the address bar. Get makes it clearly a lot less easy to mess with. I'm not saying it's not easy. I'm not saying it's hard. I don't know, but it's less easy because it's not right there in my face.
Maybe we'll get into that later.
But one of the things that they told me was a really good way to see if it's really poorly programmed is put an apostrophe in the string. So let's go ahead and let's do that. I've put in password 2. I'm going to go ahead and I'm going to erase that. I'm just going to add the apostrophe here.
Well, put password 2 apostrophe.
Password
so that we know
apostrophe.
it's not the right password to begin with.
Okay. So let's go ahead and we'll do that. And now, I don't know if you can see this, but I've got an error.
It says failure is always an option. It tells you what line of the PHP the error is actually happening on. It tells you what file of the PHP the error is being thrown at. Errors are good ways for programmers to debug and find out information, but usually you don't want the information going back to the end user or consumer of the web page because it starts giving them information. And if them is an attacker, now them gets information as to how to craft their attacks. Ruh-roh.
Yeah, so me not knowing much, just this apostrophe test gave me one piece of information that I thought was remarkably volatile, which is this. This is the actual query that it is trying to look up. And as you can see, I've got password 2, and then I've got 2 apostrophes here.
Right.
And this was, I don't know, can you see it, Max?
Yeah, I can make it out.
All right, so let me do this anyway. There you go. So basically, the query is select everything. That's what the star stands for. So select everything from accounts. In this case, accounts is the name of the database where the username is Bill Gates, or the username is equal to Bill Gates, and the password is equal to password 2. However, because I put that extra apostrophe in there, that then gives it an error. It causes an error. Because if you need an apostrophe in your query and you have 2, it's badly formed query. It can no longer understand what it's supposed to do with it. And then it throws a wobbly like this.
Right.
I don't know what you want me to do with this. You formatted it badly.
Okay, that's fair. There are some constraints in SQL, and you can learn a lot more about the SQL language by doing simple Google searches about MySQL on the how to do a select and what the from and what the where. Anything that you see there capitalized, those are key logic words for SQL. And SQL itself, almost like a programming language, has certain keywords that it reserves for itself to do certain things.
Right.
So where is the constraint that wouldn't show back everybody's information? It would constrain that information to the username of Bill Gates, as long as the and information was correct. So when we did our test, you could see that it selected everything from the username Bill Gates, right? And that's why we got back all of the different fields that were accessible to the user.
Right.
So now we threw a wobbly, as you said, and we borked it.
Yeah. So it is now effectively broken, but the problem is, what can you do with that?
So let's think about this for a second. We're breaking the SQL query in the back end with a special character that we put into the input field, right? So this is what SQL injection is. We've injected a piece of code that gets interpreted on the SQL database.
A piece of code that shouldn't be there in the first place. They don't expect it to be there.
We assume that the person doesn't want anybody to make every single query that they want to against the database.
Correct. So with this query, again, with the looking up and the research that I ended up doing, I was able to find that if you were to replace one of these key pieces, so it is saying select everything from accounts where the username is Bill Gates and the password is password 2. But you can also put in...
Actually, I'm just going to stop us there for a second. An and statement, if you recall back to earlier terribly recorded podcasts that we've done before, it means that both conditions have to be true, right? It's not this or that, it's this and that. So the username has to be Bill Gates, and the password associated with Bill Gates also has to be password 2. So in this case, it would fail because we didn't have it right. If we switch it to regular old password, both of those conditions would be true and therefore would go forward. Right. So if the username was Bill Gates 2 and the password was password, even though only one of those clauses is true, it wouldn't go forward. And that's just computer logic, right? In the back end, it's just a giant calculator that's been told how to do calculations. So if this and this are both logically true, go and do the rest of what's behind the scene.
Right. So what I'm going to do is I'm going to format it a little bit more in a mathematical type. So in an actual query, these brackets aren't there and again would cause a problem. That having been said, we're just putting this here because when I was researching it, what you can do is you can say, select everything from accounts where username is equal to Bill Gates and password is equal to password. Or, and if I throw in an or here, I can then create my own
logical operation,
my own requirement. So the easiest one is just to pick A equals A, right?
Yep.
Because the letter A is always the letter A. The number 1 is always the number 1. You could do any of these things. Now, keep in mind that when we did this request, this query, and we got this error back, it was because we put an extra apostrophe in here, and it automatically added an apostrophe at the end.
That's true.
So that having been said, if we were to try and make it so that A equals A, we could simply put that. By removing the last apostrophe, it would then close the quotes around the A and go through successfully. So now at this point, this whole section becomes irrelevant. One of these two conditions needs to be met. Either username and password have to be right, or A has to equal A.
Right.
So if I were then to put no password and no username, it becomes relevant because A will still always equal A.
Right.
So this or that. Should we try this?
Yeah, let's do it.
All right. So I'm going to go back. Yeah. I'm going to leave the username blank because it really doesn't matter. Actually, I'm going to type it in to this notepad here so that we know exactly what I'm going to type. I can't just hit enter. All right, here we go. So I'm going to put in the apostrophe because we know that that will close the end of the password.
All right.
And then I'm going to write or A equals A. It's going to write the apostrophe at the end, so it's not going to have an error. This apostrophe at the start breaks it out of its existing code. And then this is the code that I'm adding in.
It takes it out of reading and interpreting text, going back to machine or SQL language stuff.
Yeah. So all I've done here is I've copied and pasted that exact string.
Yep.
If I were to click view account details, something magical happens. I get an error.
Okay.
So probably because I did A equals A. Let's change it to 1 equals 1. God damn it.
Cool. That worked. So interesting. We can go back and fix your A equals A problem as well, because A is not, you're comparing a string to an unidentified variable. Whereas when you go 1 equals 1, the number 1 in a string automatically gets converted
into an integer.
The number 1 that's an integer. Yeah.
Okay, so for what it's worth, if we put in the 1 equals 1, with the quotes being left open or the apostrophe being left out, this will then, for some reason, go ahead and give us every single username and password created. And we can confirm that because if we look down the bottom, here is Bill Gates with the password of password and the signature of I like ducks that we created. Interestingly enough, here we've got Matt with the password and the signature of Matt is cool because you can tell I was playing with this earlier.
And you have the Max potato.
Yeah, we've got Max,
which is
potato.
Probably the most potatoes you can get.
Max potatoes. Yeah. So why then would it be giving us everything, all of the users that are in the database?
So it seems to me like it's not just looking for the one condition, but it's looping through the entries in the database. Right? So it goes, is this true for this one entry for A Baker, as we can see. And if the username and the password is not true for A Baker, then it moves on to the next entry in the database. And then it moves on to the next entry in the database. And it moves on to the next entry in the database. Right. So that's how the code is operating. But what we're doing is we're saying that doesn't matter. What we really want to know is, for this line, does 1 equals 1? And if 1 equals 1, then do the rest of what the code is supposed to do.
Right.
So we're tricking the application, right? There's a problem in the application. It's not a problem with the database. It's a problem with the application. And the problem with the application is it's allowing it to execute on conditions where things are, the default case, rather than only operating if certain conditions are met.
Exactly. So the beauty of searching a database and trying to pull information out of it is that you have to go through everything in the database to get the right information. So that's where select everything from the database named accounts, where the username is equal to username and the password is equal to whatever was the password. Mm-hmm. We could actually create the same username and password combo. Here we've got Max with a password of password. And so if we had two Maxes with the same password, and then we were to do the exact same thing, it's going to tell it anytime Max is the name and password is the password. I broke it. Max password. There you go. Anytime Max is the name and password is the password, get everything from that account. So now there's two. We've got two Maxes,
so it's
two passwords.
Another problem with the application is just not checking for the uniqueness.
Yeah.
There's no unique key in the database that it's creating and saying nobody else can have the same entry.
No one else can have the same username
or password. It just happens because there's another one that's Max and potato, right?
Yes.
Don't forget the Max potato factor.
But to be fair, usually you can have whatever password you want.
But my point is it's not actually showing Max potato here, unique. Right? Because it's actually looking for both of those conditions to be true.
Yes.
Right. So if you did Max potato, you wouldn't actually see Max password and Max password.
Right. So the way that it's going to work is it will select everything from the database where the username is username and the password is whatever the password is. So when we supersede that by saying or 1 equals 1. 1 equals 1 is always true. So select everything from the database where they exist. And that's why, as a direct result, it'll end up pulling everything. So let's go ahead once more. And it pulls every single account. As you can imagine, the simple things. So a lot of people tend to use the same password for most of their stuff on the web. And then they use the same username. If you make it so that your username is tied to your email address, then if you've got their email address and their username, they're already compromised. And everybody in this database is now compromised. I've got all of their ridiculous passwords. Which admittedly a lot of them are the word password.
It's quite common actually.
Bobby's password is password. Samurai's password is samurai because it's cool. So we took an SQL query, we injected our own code into it, and we have successfully done a SQL injection.
Yeah. Congratulations.
Pardon me.
Homework assignment complete.
Done. Bam. Thanks for watching. Bye.
How about you got bonus points?
Bonus points.
Yeah, there's got to be different SQL injections that you can do.
Interestingly enough, when we originally recorded the video, we broke it. Well, we found a new and different one. Going back to our mathematical-ish statement here, where username equals and password equals, we found that if you took our OR statement here, or 1 equals 1, and you actually put it in for the username, pardon me, we actually put it in here for the username, or after the username, it had an unusual, so let's do the close apostrophe so that we bump it out of its expected code.
Right.
And then we add our or 1 equals 1. And we know that it's going to put its own apostrophe, so we'll leave the 1 in quotes. And it had another. Oh, no, it didn't. You had to put in some kind of password.
No, you had to put in some kind of username. So if we put in Max, right, as the username.
Let me try this first.
That's an interesting one too. So you can find all the people whose passwords are passwords.
Because you say where the username is equal to anything, something specific, or 1 equals 1, and the password equals something. This isn't actually what we discovered yesterday. This is one that I discovered earlier, and I was just
look at you with your extra credit work.
Oh, look at me with my extra credit work. So yeah, anyone who uses a terrible password is fairly easily corrupted or co-opted or whatever. The other thing that we discovered was if you put an actual username, Max. Actually, let's use Bill Gates. And then we put in our or 1 equals 1. So this is going to go ahead and let us in without any password. Right? We left the password completely blank. So how is this working now? Now we've got where the username equals something or 1 equals 1 and the password is blank. I don't get it anymore. It made sense yesterday. So now we're looking at this, I think. No, that's right. Where username equals something specific or 1 equals 1 and the password is anything.
That doesn't work either, though, because the password is not null. The password is password. So somehow the logic behind it is saying where the username equals... Maybe it's processing it backwards. Maybe the application is saying where the password, when it comes time to do the actual code understanding, where the password equals blank and the username equals this or this. Actually, it'd have to be all backwards. So it'd be where the password is open parentheses, close parentheses, so null, or 1 equals 1, and the username equals, something. the actual correct username, then it would return the results.
So I wonder if there is an order of operations to SQL queries.
That could be.
Hey, we're learning along with you. So
Yep.
This is a thing. The original one made a lot more sense than this second one, but the second one was the one that we found first. Who knew? Did you find any other good tricks that you wanted to share?
I didn't get an opportunity.
Perfect. So, all of that said, this main problem is brought about by this little guy, the apostrophe. The apostrophe is lovely. If, for instance, you want to try and put it into some sort of query or some sort of form where it's the result is wrapped in apostrophes, it's going to end up breaking it unless you escape it. And in a lot of these languages, there's an escape string that you put before an apostrophe so that when it gets dumped in to the code, it'll just ignore it and read it as an apostrophe. And a lot of the more modern programming languages have built-in ways to automatically escape everything, so that you don't actually have to do most of the hard work.
Right.
At that point, you're basically just looking at find a way to make it so that whatever ends up being put into my database is fine. I'm just going to treat it as text. I'm not going to treat it as code.
Mm-hmm.
And that one simple trick, with this one simple trick, hackers hate him. That's pretty much it. That fixes it, right?
Yeah. You can also filter out the individual characters that you think are going to be problematic. However, the fact that we have so many different languages and keyboards that can work, we've got something called Unicode, which allows people to put in strings that might look like normal strings, yet get interpreted by the computer in a completely different way. So that's something to be cautious about if you're going to go down that route. Not a fan of blacklisting, definitely a fan of whitelisting things. So instead of saying, no, not this, but everything else is okay, going about and saying,
your password is
only these
too
things
complex.
are okay.
You have to simplify your password a little bit. You've got too many weird characters in there. We can't handle this. This is out of control.
That's a very good point. If you ever see something that says, oh, you can't have a weird character in your password, that's kind of a sign that they, as a web
discovered a
port,
problem
aren't
and they were too
mature
lazy to fix it.
Yeah, that they haven't done that escape character for the input that gets put in there. And there's other things that you can do. You can also do stored procedure calls in SQL, which basically doesn't matter what somebody throws at it as input. It will just take it all as if it was a string, no matter what gets put in there.
You're either really good at popping and locking or your video's getting a little bit choppy.
Mm-hmm.
So as we near the end of this whole, I guess, episode, for lack of a better term,
I think the problem is that this is our attempt number 2, which everybody knows is the electric boogaloo. So that's why it's popping and locking.
No, exactly.
No, nothing else. Thank you for coming through this adventure with us. Let us know if you actually enjoyed this. You can email us to feedback@in-security.org. You can leave a comment to this. You could always just thumbs up if you don't want to actually have your name associated with it, but still want to convey
and
thanks.
Subscribe. That'll help us out.
Yeah, subscribe.
That's the
help
YouTube
us out. It would help us out if we got money from it, but we're not getting any money from this. So
not monetizing yet.
At least it's a little bit of feedback that somebody's watching this. So yay. That's good. Good enough to keep us going, apparently.
Yeah, exactly. Follow us on Twitter at Insecurity Show. Send us email to feedback at in-security.org. Visit our website at in-security.org for other episodes of our podcast, to leave comments, all that. I did have one other quick thing, one string of code that I really wanted you to check out here for us. I got it right here.
Have yourself a great week too, Matt.
All right. Thanks for watching. Have a good one.
Thanks.